Hello, everybody. Good evening from the UK. So while we're waiting for everyone to come in, just for anyone who doesn't know me, I'm Claire. I'm one of the TAs at Launch School. I'm a student, also a student, and I'm in the front end of the core curriculum. This is the fourth in a series of introductory workshops on Python. These workshops are designed to complement Launch School's programming, the back-end prep Ruby course. As an introduction, they'll give you a flavour of Launch School and what to expect, but they're not a substitute for working through the material. Here, let's have a look at what we'll be covering today. So today we're doing lists, dictionaries and sets, and we're going to do a refresh on collections. We're going to look at indexing and key-based access, so how to get things out of collections, collection operators and methods. Then we're going to have a look at for loops, and then finally we're going to have a look at comprehensions. They are such a great tool. I found them a bit intimidating when I first started using them. Wasn't entirely sure what was going on, but now I can see they're a really neat syntax for making transformations and selections. They're great. So if you've got any questions as we go along, please put them in the Q&A. They might get lost in the chat. I'll try to answer them as we go because I don't want to leave anyone behind. This is a beginner session, so any question you're thinking, other people are probably thinking too. Anyone that needs to go early, please grab the feedback forms. I'd like everyone to fill this in, please. And this is the first time we've run these Python workshops, and so it's really useful to hear the feedback. What's worked, great, but also what hasn't worked. So I can adapt them for the next time that we run them. As I said, everything in this workshop is covered by Launch School's Python books, so you don't need to worry about taking notes. If you would like to code along with me, then please go ahead. Don't worry if it doesn't work for you. It's going to be interactive because I'm going to be using multiple choice quizzes throughout to keep things interesting. They're just for fun. They're anonymous. I can't see who answers what. I can see like a distribution of answers, so it gives me a vague idea of whether or not I've explained things well, but no one's recording anything and I can't see which individual has answered anything, so just give it a go. We recommend using a Mac and Visual Studio Code, which is what I'm going to be using, but if you've got a Windows machine or you need to use Amazon's AWS Cloud 9 services, it's fine too. Launch School's Python book has got instructions on how to get that up and running. Any problems, just reach out to us on Slack. There's a prep course channel, especially for people in the prep course. So again, we expect questions in there to be things like, how do I set up my environment? And there's loads of people around to help. So please reach out if you do have any issues. So let's get going then. So I'm just going to escape out of that. So firstly, we're doing a refresh on collections. So in the student notes, I've got the 3 types of collections we're looking at today: lists, dictionaries, and sets. And there I've got some examples, and we're going to use these particular things, fruit, books, and creatures, as we go through and do different things with these different data collections. So data collections are objects that contain 0 or more objects. Python's got a large number of types from which to choose from, which is why what makes Python so popular. And we're just going to focus on these 3 today. All of these 3 are mutable. So once the collection is created, we can change what's in it by adding new things or removing some things. So firstly, lists. These are ordered. So we can rely on the sequence of the objects in the list remaining fixed. They can contain any data type, and they can even contain mixed data types in the same list. They can contain duplicates. And in Python, they're denoted by being surrounded by square brackets, and items are delimited by commas. Throughout this workshop, we're going to work with a list of fruit. Dictionaries contain paired data with a pair consisting of a key and a value, just like a dictionary where we have a word paired with a definition. Keys must be unique within the dictionary and can be any data type that's hashable, is the technical term, but we could just think of it as being immutable. There are slight differences, but we don't need to know about those now. So as long as the data type you're using for the key is immutable, so it can't be changed, like integers, strings, not lists, dictionaries, and sets, because as we've described, those are mutable. We can add and remove elements, so they can't be keys. They're denoted by curly braces. Each pair is delimited by commas, and then the colon is separating the key from its value. And we're going to work with a dictionary of books containing the titles as the keys and the year they were published as the values. And finally, we've got sets. So just like the keys of a dictionary, the elements in a set must be unique to the set. So you can't have duplicates, and they must be immutable. But like lists, they consist of single elements rather than paired data. In Python, they're denoted by curly braces, delimited by commas. And so our set is going to be a collection of mythical creatures, which you can see in the student notes. So let's now have a look at how we can access specific elements in a collection. So there are two ways: indexing and key-based access. For lists, we use indexing. For dictionaries, we use keys. I'm not going to talk about sets because you don't access elements in a set. You use them to determine whether something is in a set or not in a set, and we'll do that in the next section. So this section, we're just going to be doing lists using indexing and dictionaries using keys. So if you're coding along, I'm just going to paste in the chat a gist link. So this is on GitHub. You don't need an account on GitHub or anything. Just click on the link. I'll show you what it looks like. Click on it, and then you can just copy this code. So I'm going to go into the Python REPL where we can just write code and we press enter and it executes it. So I don't need to create a file and run the file. And to access that, I just type Python. If Python doesn't work for you, try Python 3. It's worked for me. And then I've got Command K to clear my screen so it's all uncluttered. So the first thing I'm going to do is paste in that list of fruit. So I've got my apple, banana, apple, kiwi, and lychee. So that's bigger, but then I lose less. Okay. So how do we access the first element? We do fruit, then we do square brackets, and then we do the index of the element that we would like to access. Lists are 0 based. So the first one is at position 0. Then if I want to access, say, the one in the 4th position, I use the index 3. Python handily also enables negative indexes. So if I want the last one, I can do -1, and that will give me the last one. If I want the penultimate one, then I can do -2, which is really handy. If I do one that doesn't exist, I get an error. Python doesn't fail silently. It says, well, there isn't an index 99. There aren't 100 elements in this list, so it's an error. You can also use indexing to mutate the values in a list. So again, I'm just going to clear screen and then get the fruit so we can see it. So we've got the fruit. So if I want to reassign that first element, I don't want the first element to be apple, but I want it to be pear instead. I use the indexing syntax, and then I just assign it to the different thing that I want it to be. And then if I type fruit, I've got pear in there instead. What I can't do is do this for a index that doesn't exist. So there aren't 10 pieces of fruit in here. So if I try to reassign the piece of fruit at index 9, I will get an error. Now, that's how to access things in a list. And now we're going to look at accessing things in a dictionary. So again, I'm just going to clear the screen. Put another link in the chat so you can get the dictionary. And then I'm just going to paste that in here. So now I've got my books. So rather than using my indexes of 0, 1, 2, 3, 4 and negative ones, I now use the key to access the particular value. So if I want the year for the book Emma, I put the key inside the square brackets. So I get 18, 16. If I try and do one that doesn't exist, I get an error, and make sure that they are exact matches. So because my keys are strings, they are case sensitive. And so if I use a lowercase Emma, I get an error. To avoid that error, I can use get. I'm going to use the print here so you can actually see. So if I do books.get and then Emma, close that out. I'm printing this so we can actually see it. We get none, which can be useful because sometimes you don't want an error. You want to know that it doesn't exist, and so you can use .get instead of using the square bracket notation with a key inside. Similar to indexing, we can use the key-based access to mutate a dictionary. So again, let's clear that. Like that so you can see them. So if I want to change the year in which Emma was published to this year, then I can do that. And so now if I look at books, I can see that's changed to 2024. And I can create an entirely new pair by adding in a new key. So here it's 1897. I can add Dracula in. And then if I look at books, I can see that Dracula has been added. Yeah, so that's a way that you can add a new key value pair to a dictionary. Okay, so enough of me talking. Let's have a quiz. So let's clear this. So like I said, just for fun, there's only 3 questions on this, so I'm starting quite gently. So give it a go, and then we'll go through the answers at the end. And I'll give you another 30 seconds or so. Let me know if you need more time. Let's have a look at the answers. So I can share the results so you can see the same thing that I can see the distribution, and then get the answers up here. So for the first one, so for lists, we need to use square brackets. So I can see actually that everyone always selected ones with square brackets. Lists can contain mixed data types. So this second one is a valid, let's make this a bit wider. So we can see this second one, that is a valid list because you can have mixed data types in there. This is a valid list as well because we can have an empty list inside a list. That's valid too. This isn't valid because this is curly braces, so that makes it a set. This isn't valid because it looks like we've mixed up lists and dictionaries here. So to have a key and then a value isn't valid for a list. For question 2, which are valid dictionaries? They've got to be curly braces, which they all are here. The first one is because we've got a curly braces, and then we've got a colon separating the key and the value, and we can use a string as a key because it's not mutable, so that's fine. The second one, though, isn't valid because we've got a list being used as the key, and we can't use a list as a key because it's mutable. And the last one is okay because Booleans are immutable, so they're fine to use as keys. I mean, it does mean you're quite limited if you're just going for Booleans as keys. But it's perfectly valid to have. So this last one here is also a valid dictionary. And then for sets, so the sets use curly braces again, like dictionaries. And they can contain any data types, but they've got to be unique. So that first one isn't a valid set. They can contain mixed data types, and as long as the data types aren't mutable, we're fine. So having 1, 2, 3 and having 1 in the string A is fine. So it's the only the first one that wasn't valid. Okay. Probably quite hard to see those in the quiz, so don't worry if you weren't familiar with those, and the more you use them, the more familiar you get. So this is just a random picture I got out here as a telephone operator. So we're going to take a look at operators and methods that we can use with collections. So Python collections support many operations and methods, making collections great to work with. We're just going to look at a few to get you started here. And the first operators we're going to look at are the in and not in, which we're going to explore with our fruit, books and creatures. So I'm just, again, going to put GIS link in the chat for anyone that wants to code along. And we're just going to paste in my collections again so that they're back to what I want them to be. Screen. So I've got my fruit, I've got my books, and I've got my creatures. Except I can't spell creatures now. I need to do it over again. So, come on. Fruit, books, creatures. There we go. So first of all, let's use the in operator with a list. So we do apple in fruit. And that returns true because apple is in there. Again, this is case sensitive. So if I do it with a capital A and I do it in fruit, we get false it is. It's a really neat way of letting you know whether or not an item is in a list. And there is a not in. So if I do apple not in fruit, I'll get true. But if I do apple not in fruit, I get false. So the not in just returns the opposite of in. But again, it's quite handy that you don't have to reverse things in your head. You have got the in and the not in. With a dictionary, we can check whether or not the keys are in the dictionary. So Emma in books returns true, but it doesn't look for the values. So if I do the year 1816 to see if it's in books, I get false. So for dictionaries, the in operator and not in are just looking at the keys. So again, if I do 1816 not in books, I'll get true. Let's clear this through again and have a look at the creatures. So we've got a set here, and this is how you interact with sets, because you just want to know whether or not something is in a set or not in a set. So unicorn in creatures, yes, it is. Wizard in creatures, no, it isn't. And then we've got the not in as well. Okay, so in and not in work for lists, dictionaries and sets. Now, there are also a couple of other, there are loads of methods, but we can have a look at a few. So we're going to have a look at index and count with lists, really useful methods. So let's look at our list again. So we've got our fruit. If I want to find out the index that banana is at, I do fruit.index. So I'm invoking a method on my data collection, and then I pass in the value I want to look for. It will return the index of the first occurrence. So if we do this with Apple, I'm going to get 0. It appears twice in there, but it's only going to give me the first one. And if I look for something that doesn't exist in there, so I haven't got pair in there now, it gives me an error. Then count, so we want to know how many times something appears. Again, we've got the variable that we've that's referencing our list, and we do count. It's going to be most interesting with Apple because we're going to get this in there twice. If I do banana, it's in there once, and if I do pear, it's not in there. So index and count, really useful working with lists. They don't work with dictionaries or sets though. For dictionaries, we've got keys, values, and items methods to extract information. So let's have a look at our dictionary. First of all, if we want to just pull back all of the keys, we do books.keys. And here, this is invoking a method, so we need the round braces after the method name keys, even though we're not passing an argument. And that will give me a dictionary view object, which I'll explain in a minute. Basically, it looks like a list, so it's a list of all the keys. If I want the values, then you won't be shocked to know that it's just values. And there's also another one, which is items, which gives you a nested pairing. So they're tuples that are nested inside like a list-like object. Now, I want to explain what these dictionary view objects are. So if I do books keys, and I'm going to assign it to the books.keys. Okay, so if I look at books keys, I've got just the keys. If I then add a new book to books, so neverwhere, and that came out in 1996. So now if I look at books, I've got neverwhere in there as well. If I look at books keys, that's also got neverwhere in there as well. So that's how these dictionary view objects are a bit different. They look like lists, but they're not, because they're tied to the dictionary that created them. So if the dictionary is mutated, like adding a new key value pair or removing one, the dictionary view objects are also updated automatically without you doing anything. So it's just something to be aware of. So that there we added a new key value pair to a dictionary by using the key access notation with square brackets. So a new key and then giving it a new value. Let's now look at adding new elements to lists and sets. So, okay. So first of all, let's have a look at the fruit. So here are our fruit. If I want to add elements to it, I use the method append. So here I can append pear. And so now if I look at fruit, it's got pear inside it. If I want to add elements to a set, so I've got my creatures, I use add. So I do creatures dot add, and I'm going to add a troll. So now when I look at creatures, I've got troll in there as well. Interesting that it wasn't added to the end. That's the thing with sets, you can't rely on their order. You don't need to anyway, because you can't access them through their order either. Something's either in it or it's not in it. So we use append up here to add elements to a list, and we use add to add elements to a set. So for sets, start again. So for lists, you can add duplicate elements. So let's just have a look at that. So we've got fruit here. We know that we've got apple in there twice, but we can also add pear in there twice. And that's absolutely fine, because we know that lists can contain duplicate values, but sets can't. So what happens if we try to add a duplicate one? So I'm going to add, and I'm going to add troll again. So if I try to add troll again, I don't get an error. It's already in there, but Python doesn't raise an error. But when I look at creatures, it's still the same. It hasn't added that extra thing. That's quite handy, because you don't need to check whether something is in there when you want to have it included. You can just add it in there. If it's already in there, then Python doesn't mind. But it is something to be aware of, that if you are expecting everything you're adding to be unique, Python won't say, whoa, this isn't unique, but it won't affect the integrity of the set. So we've added things to each of these. Let's now remove things. And to remove elements from a list, we use remove. So we do dot remove, and then we do the element that we want to remove. Let's do banana. So now if we look at fruit, we can see the stuff that would be on the banana has all been shifted up, and the banana is no longer there. If we remove something that appears twice, like apple, then if we have a look, we can see it only removes the first instance of it. Again, something to be aware of, because that's not necessarily what you would expect. So to remove both of them, I'd have to remove apple twice, and now it's no longer in there. So remove will only delete the element that appears. If it appears more once, it only deletes the first one. To remove a element from a set, we use remove again. So I've got my creatures. If I want to remove troll, and have a look at that, I can see troll has gone. And it will raise an error if I try to remove something that is no longer in there. So if I try to remove troll a second time, I will get an error. What happens with a list if I try to remove? So I haven't got any apples in there anymore. Same thing happens with lists and sets. If you try to remove something that doesn't exist in there, you will get an error. Then to remove something in a dictionary, we use del for delete. So this is right, let's do this. So I'm doing dictionaries as books. So I use a function invocation, so del, and then I pass in the dictionary that I want to delete something from, and then the key of the key value pair that I want to remove. So I'll pass that in. Now, if I have a look at books, I can see that Emma is no longer there. And then let's have a look at what happens if I try to delete something that isn't there. I get an error. So Python's pretty consistent with this, which is really great. So we use remove for lists and sets, and we use del, delete, to remove things from a dictionary, and then we specify the dictionary we want to remove it from, and then the key to be removed. And lastly, we can compare collections, which is really handy. So, not bitter about this at all, because in JavaScript we can't do this. That's JavaScript that I'm currently grappling with. If you compare two different lists that have the same things in the same order, JavaScript says they're completely different. Python is much more sensible. Python's much more sensible, and if you've got two lists with the same things in the same order, it does say they're the same. I'm distracted because somebody's asked a good question. So before I move on to comparing them, does remove also cause the sort order to change? So let's have a look at our fruit. So yes, it does, because if we remove kiwi, and then have a look, because kiwi's now gone, everything's shifted up. And then sets obviously don't have an order, and dictionaries don't have an order. So we don't mind whether or not it changes the order. So, great question. So now we are going to look at comparing collections. So I've put a new gist link in there because I've got two lists, two dictionaries, and two sets. So I've pasted those in. Let's have a look first. We've got books and books two. We can see they are exactly the same. They are different. I've not assigned books to books two such that they're both pointing at the same. We should be looking at fruit first. So we've got fruit and fruit two. So these are both lists that contain exactly the same elements in them in the same order, but they are not the same list. So I haven't assigned them to point to the same thing. They just happen to both have the same thing in them. And so if I do fruit and use the double equal sign, fruit two, Python says, yes, they are exactly the same. We can tell that they're not pointing to the same thing by appending something to the first one. And if we look at fruit and then fruit two, we can now see that they're different because I've added pair to fruit, but it's not been added to fruit two. And so now if I compare fruit and fruit two, Python says, yeah, they're not the same. They don't have the same elements in the same order because there's an extra one in fruit. We can do the same with dictionaries. So if we look at books and books two, then if we compare them, as long as they've got the same keys and each of those keys has got the same value, then Python will say that they're true. So if I reassign one of the values, they will now no longer be the same. I didn't use double equals. Oh no, so I've ruined it completely. I need to do books. The books equals this, and then I need to change it. So I've got books. Okay, I have neatly demonstrated the dangers of confusing equals and double equals, which is obviously a deliberate mistake and something that I wanted to bring to your awareness. So now I have changed the value for the Emma key, but just in books. We can see that they're different for books and books two. If I now do books and use the double equals, books two, we can see that they are now different. Be careful because a single equals is assigning values to variables and the double equals is comparing them. So if you accidentally do an equals, you reassign something rather than comparing it. For dictionaries and sets, order doesn't matter. So that's, even if we created a, I should demonstrate this. So let's books 3 equals, let's, I'm going to copy this in to save you watching me make typos. So I'm just going to add the L1 in at the end. And I'm going to assign that to 2024 because that is what is in books. So let's just say we've got books, and we haven't got books, and then we've got books 3. Now, if we compare them, they are the same. So for lists, it needs to, because the order in lists matters, when Python compares them, the items have got to be the same and they've got to be in the same order. But for dictionaries, there is no sense of order. So as long as there are the same keys and each of those keys has the same value, then Python says they're the same because the order doesn't matter. We can see the order is different here, but actually, as far as Python's concerned, it's not looking at the order inside a dictionary. And we can also, is there a sort command? Yes, I'm not going through that today, but let's have a look. So if we do fruit dot sort, I don't know if you have to pass anything into that. I want to print it out, don't I? None. No, I need to look that up. I'll look that up while you're doing your next quiz. It's because I get confused between the 3 languages. Okay, and then we can also compare sets. So we've got creatures and creatures 2. They're the same, got the same things in them, but if I add something to creatures like troll, now they are no longer the same. And then there is also a not equal to, which is handy. So we can do is fruit not equal to books. Yes, we get that's true. So the bang equal sign just returns the opposite of the double equals. So we have looked at a small subset of what's available in Python to manipulate and interrogate collections. Launch School's Python book contains many more examples of methods and operators and lots of exercises to practice them as well. But for now, let's have a quick quiz on collections and operators. So these are the 3 collections that you'll be using for this quiz. You've got Pythons for the lists, characters for the dictionary, and movies for the set. And you've got a nice 7 questions here, which gives me plenty of time to look up the syntax of the sort command. Oh, sorry. Okay, I'll give you another 30 seconds or so because I can see most people have finished it, but there are still a few more. Okay, so let's have a look at the answers. Show results. No, this is like, sorry. Right, so the first question. What does Python's 1 return? So Python's 1, gosh, it might help if we actually have them, mightn't it? Let's copy them out so we can see them here. Okay, so we can see Python's 1. We get what's their 0 index, so we don't get Graham, we're going to get John. Python's 5, we're going to get an error because that's what Python does if you try to access a index that doesn't exist. Then how can we delete Eric? We use the del keyword to remove Eric from a list. No, we don't. I'm looking at the wrong one. We use remove to remove something from a list. We use del just for the sets. Then what characters? I'm just going to check that. What do we use del for? No. We use remove for lists and sets, and del is for dictionaries. Then we're moving on to the gumbies. So we're looking at characters and we are passing in the gumbies, but we get an error because strings have got to be an exact match. The keys have got to be an exact match, so they're case sensitive, and we didn't capitalize the T in the. So we get an error. Question 5, for characters, how can we add a key value pair? You don't need to use add. Add is for sets. We just use the key indexing. So we just have the name of the dictionary and then the key and then the value that we want to assign to it. For movies, that's a set. If we want to check whether or not Life of Brian is in the movies, we use the in operator. So it includes, and that's something that is in Ruby, but in Python, we just use in. And then what will this return? So here we've got a set of Graham, John, and Terry being compared against another set of John, Terry, and Graham. These look like they're in different orders, but these are sets, so the order doesn't matter. So we're going to get true for this because all sets care about is whether or not the same elements are in there, whether or not they're in the same order. It's only lists that care about the order. Lists are an ordered collection, so it matters. Right, so before I move on though, I had a question about sort command, so let's put my fruit, which I've already ordered, so just going to change my fruit back to what it was before, or it wasn't ordered. So now it's not ordered. And it is dot sort with brackets after it is just that this mutates. So I can, and it returns none. It doesn't return a new list with it sorted. It mutates them in place and it returns none. So if I have a look at fruit, I can see that it's sorted. Whereas if I don't want to, I see, yeah, if I do fruit dot sorted instead of sort, I'm sure you can do it. Is it? Let's just check fruit still exists. I'm sure I just looked at this. I'm getting confused with JavaScript. Oh, no, you can't. In Python, you can't. In Python, there isn't a built-in method for sorting something and creating a new list. You have to create a copy of it, either a shallow copy or a deep copy of it, doesn't it? You create a copy of it and then you sort that. Yeah, thanks, Jules. So sorts it in place, so it's mutated my, if I've got fruit, if I do fruit dot sort, that hasn't worked because I didn't spell sort right. If I do fruit dot sort and then have a look at fruit, it has sorted them in alphabetical order, but it's sorted them in place. It's not created a new list. So great questions. Thanks for the help, Jules. And you're welcome. Done. Right, so now we're going to have a look at for loops. Fine. Okay, so most languages provide a for loop to enable programmers to repeat a set of instructions, and Python has got a particularly elegant way of doing this. So first of all, let's loop through each of the collections. So I'm going to put my fruit back to what it was before. And so to loop through it, you just do for, and then I'm just going to say item with item of fruit. Maybe I should do piece of fruit. In fruit, so I've got for, piece is like a local variable that I'm creating in fruit, then the colon, and then I need to indent to put stuff inside my for loop. And here I'm just going to print each piece of fruit. I have to press for this enter twice for Python to know that I finished my for loop, because I'm in the REPL. So make sure when you are in the REPL and you're creating a for loop that you indent the code that you want to be inside the for loop, and you press enter twice to get it to actually execute. And as ever, Python uses the indentation to know when something has ended, so it knows when you're outside of the for loop because the indentation has ended. Looping through a set is similar. So if I've got my creatures, again, let's. Oh, got my creatures here, and it's the same thing. So I'm doing a for. I'm going to do creature in creatures, my colon, make sure I indent, and then the code I want to execute each time we go round. Oh, this isn't going to work because I put an S. I just automatically put S on creatures. So we want for creature in creatures into creature. Okay. Oh, that's because that's a set. That's interesting. I've never tried this with a set before. Because creatures only is only fairy. Okay, right. I was very confused there. Now I'm no longer am. So wait a minute. So we've got fruit. We have looped through piece in fruit. and we're going to print. We're going to print this. So we've got that. Now we're going to have a look at books. And here, if you use let's just start again. So books. If you use a for loop for this, so it actually logs the keys. So I'm going to put title so it's clear. So for title in books, if I loop through a dictionary, I'm actually looping through the keys. So if I do print title, you can see I get the keys of the dictionary. So when you use a for loop, without doing anything else, a for loop with the dictionary, you're going to be looping through the keys. If I want to loop through the values, then I can do books.values, as I showed you earlier to get them. Or I didn't use the for year in books values. I have the print year, and then I get the years. And if I do the same, but I do for items, forget that. Oh no. Right. What I'm going to do here, so if I do items, let's use books. So for book in books.items, I'm going to print the book. I get key value pairs, which the title year pairs in here. What I can also do is separate these out. So I can do for title year in books dot items print, and then let's use an F string so I can interpolate some variables in there. I can do title published in the year. So yeah, I'm going to print out each title published in the year. I didn't end the F string. So let's go there, indent it, and make sure that I end the string. Then I get Emma published in 2024, etc. So that's quite a neat way of doing it, where you can separate out the key and the value by creating local variables for each of them inside this for loop, and using the items method. Right. And looping through a set is very similar. So let's create my set. Here, so I've got features. And so if I do for creature in creatures, I'm going to print creature. I get each of the creatures in there. Yeah. Now, that leads us neatly on to our final topic. So I'm running a little bit over, sorry. So anyone that needs to leave early, I'm going to put the feedback form in, but I'm here until the end. So anyone that wants to stay is welcome to stay. So we're going to do comprehensions. Now, comprehensions are a really nifty tool in Python, can get a bit of getting used to, so practice, practice, practice. There are 3 comprehension types: a list, a dict, and a set. Now, I'm only going to cover list comprehensions today, but Launch School's Python books explains the other 2 and contains lots of exercises to get familiar with them. And that is just key to, well, for me it was, to really get to grips with them. Now, list comprehensions are used they iterate through the list and transform each element in that list. So yeah, let's just check that my fruit are still there. So I've got my fruit. If I want to transform my fruit to uppercase, I can use a list comprehension. It's a list comprehension. So it's going to start with a square bracket. And then I'm going to do the thing that I want to happen to each element. So I'm going to use the upper method. And so when I invoke the upper method on a string, which is what is in my fruit, it transforms them into uppercase. So this is what I want the transformation to be. And then after that, I have like my for loop. So I'm doing for item in fruit. So that is, this item here is where that item comes from. So I'm looping through for item in fruit. I want to uppercase each of them. And when I execute this, it returns a new list. So it has done nothing to the existing list. It's still there, but it's transformed each element in my list to uppercase. Right. You could capture that in a variable if you want to use it later. So I'll just do, I'm not very original, upper fruit. And then I can see upper fruit is that, and fruit is this. So I've created two different lists, but I did it using a list comprehension to transform all of the elements in the first list to create the second list. So that's the first thing that list comprehensions do, is transformation. They also do selection. So here, again, I'm going to do item for item in fruit. So I'm not transforming this one because I'm just returning the item, and the item is from this sort of for loop that's inside the comprehension. So each item in the fruit list, I'm just returning it, I'm not transforming it. And then after it, I can put an if condition. I'm going to use the len function, so that just returns the number of characters in a string. I can pass in item, and I want only those that have 6 characters in them. So it can feel like there's a lot in here, but actually we've just got this for loop here that we covered before. We've got a condition here, so it's only going to select those ones where the item is 6 characters long. And what it's going to return in my new list is just the item itself. So when I do that, I'm just going to get banana and lychee. And again, it hasn't changed my original list. It's created a new list. And we can do both selection and transformation at the same time. So here, now I've added that in, I'm only getting the fruit that is 6 characters long, and I am transforming them into uppercase. So this is really neat, quick way of doing things. Practice with them. I did find that, I don't know, I found them just a bit tricky when I was first coming across them. But once I think I realised that they are just a for loop, but then this bit is the transformation, and then this bit, or not just that bit, and then this bit is the selection. It didn't look like there was so much going on. But that's a fraction of the power of comprehensions. They can be used for multiple selection criteria and to iterate over multiple collections at the same time. That's only list comprehensions. Dictionary and set comprehensions are similarly used to create new dictionaries and new sets, respectively, by transforming and selecting things. I'll leave you to explore those yourselves. That is all in Launch's Python book, as I've mentioned several times. Yeah, and they're just a really neat way of doing this. I love comprehensions. Okay, so now we're going to have a quiz on for loops and comprehensions. There's only 2 questions. So let's start that. Give it a shot. Don't worry if any of this is a bit unfamiliar. I'll explain it at the end. Some of the syntax might be a bit new if you've not spent time manipulating strings and lists, but don't worry about it. Just give it a go, and then I'll go through the answers.
I'm looking at question 2. Yes, Launch School's Python book is available to non-paying, non-registered students. If so, how can it be accessed? Right, let me bring up. So much going on my screen. It's hard for me to books. Right, all my books. All of the books are available without subscribing. Oh, I don't know. You might need to register with Launch School though. But you can register without subscribing, because actually to subscribe to Launch School, you have to complete the prep course and then email into Launch School answering some questions before you can start paying for the paid courses anyway. Yeah. So I think you might need to register. I don't know that you do. Anyone who's not registered with Launch School, if you click on the link and tell me whether or not people need to be registered, I think they don't. Right, okay, so let's have a look at the answers. Sorry, I just abruptly stopped that and didn't even ask for everyone's range. Sorry about that. So for the first one here, we are looping through a dictionary. And remember, for a dictionary, if you don't do anything else, you're just going to be looping through the keys. So this will output Romeo and Juliet, art, and the mousetrap, because we didn't use plays.values or plays.items. If we don't use anything, the dictionaries, the for loop is just looping through the keys. The second one, this is quite complicated. So, first of all, let me do this in the REPL. So I've got my movies over here. Unexpected indent. Yeah. Okay, so now I've got my movies. So first of all, I'm just going to do a simple for loop. So for movie in movies, print movie. I think I can do this all in one way. Yes, I do. If instead I want to print movie, but I'm going to split it, what split does is it takes a string and it turns it into a list where each item is each word. So it's splitting it here because I've passed in a space as the argument. It's splitting it into words. So here we can see I've got a list for each movie, and the guilty and the gift have been put into a list with 2
items because there are two words, whereas scoop has just got one. So therefore, if instead of printing the return of that, I actually just access the first elements in there. So the element at index 0. Oh, it's all gone a bit squiffy. So here, if instead I just access the 0, 1, then I just get the first element in each of these lists. So I'll get scoop the. So the next part of it is now, if we turn this into a comprehension, so I'm just going to return movie for movie in movies. And here I'm going to use I'm going to do my selection here. So I'm going to do if movie dot split, and I'm splitting on the spaces. And the first element is the. So here, I just want to return the movies for when I split that string by spaces, but I just look at the first element is the. So this is the way I can just check that the first word is the. If I do that, I need to end it, then I'm just getting the guilty and the gift. But if instead of returning the whole movie, I just want that second word, again, I split it and just bring back the element that is at index 1, which is the second word. And so I'm getting guilty and gift. So that was a very long-winded way of saying that the answer to the second question is guilty and gift. And do not worry if you did not get that correct, because that is the most complex thing we have looked at today. But when you get something like this and you're not sure what it does, just break out each bit. So first of all, just for movie in movies. Then I looked at what the split function was doing. Then looking at the first index and then using the selection and then adding on the transformation after. So don't worry about trying to understand the whole thing together. Just simplify it till you can understand it and then add the more complex things on after. Right, that was what we've covered. We did a refresh on collections. We looked at indexing and key-based access. We looked at collection operators and methods, for loops, and then lastly, we looked at comprehensions. Now, I've got a question which I am going to answer. I have got another quiz. Do people want it? Also, if you've got any questions, now is the time to put them in the Q&A and I'll answer them before I go. I don't mind going over quiz 2, question 2 again, but I will do that after I've answered all the other questions. How are people feeling? Yeah, you see, I only need one person to say, sure, do the quiz. So round up quiz, let's start that off. And that gives me a chance to think about questions. So I've launched that, 7 questions. Give it a go. Gluttony for punishment, John. And then we'll have a these. So thank you, Lyndall. I will do that. Okay, I will give you another 30 seconds or so. Let's have a look at those answers. I'm sorry, there's one person that hasn't finished. Sorry. Let's show results. So the first one, what's missing? So here we've got a list. Oh, everyone got that right. It's the commas that are missing between each of the items. For the second one, it's a colon that's missing because this is a dictionary, and everyone got that right. Brilliant. This is a dictionary, we need a colon between the key and the value. Here, question 3, trick question, nothing's missing, and you all got that right as well. That's the set, got everything we need in there, so nothing is missing. So if we've got fruit equals our apple, banana, apple, kiwi, lychee, which of these would return banana? There's 2 of them would return banana. So again, maybe a bit of a trick question, that one. So everyone got the first one, fruit 1. But fruit -4 also brings back banana because Python supports negative indexing, which is really useful when you using a language that doesn't is a bit of a pain in the neck. So we've got -1, -2, -3, -4, so we get banana. Remove can be used to delete items from which collection types? It's lists and sets. For dictionaries, we use the del function. What does this return? So we've got 2 lists here. We've got ABC and CAB. That returns false because when you're comparing lists, they've got to be the same elements. They've also got to be in the same order. If these were sets, it would return true. But for lists, the order matters. So these 2 lists are not considered to be the same by Python, and it will return false. And then comprehensions can be used for both transformation and selection. So we saw that by uppercasing our fruit. Great. So the questions, I've just got 2 questions. So Shelby's asked me to go through that quiz 2, question 2. Okay, so I have to go back to that. But before that, EJ has asked, does the variable in for loops only exist for the duration of the loop, or can it be accessed later? It can be accessed later. I've just learned it. So we've got our fruit. And if we do for, I need to use something I haven't used before just to convince you and myself. Let's do gobble. For gobble in fruit. We're going to print gobble. So we get all of them. And then if I type gobble, I get lychee. So gobble exists. So I created a new variable in the global scope there that can be accessed outside. So it would have been apple on the first iteration, then banana, apple, kiwi, lychee. And because the last item of fruit that it would have been assigned to is lychee, that's why it is returning lychee when I'm now after I've done the for loop. So I've learned something new there. Local variables created in for loops do persist after the for loop has finished. Right. Question 2. Quiz 2, question 2. Right. Yes, so you do need to be careful about what you name variables in for loops. Before I move on, let's if I create a variable out here, I'm going to call it plan. And then I've got my for loop here. What is bubble now? It did reassign it. You're absolutely right, EJ. You need to be very careful of what variable names you use in your for loops, because they could reassign something that's way up before your for loop. Gosh, that's such a great question. Right, what was I looking for? Quiz 2. So quiz 2. Effects. Quiz 2 was on collections. Shelby, are you still here? Yes, you are. Do you mean quiz 2, question 2? Because that was quiz 2, question 2 was where we were pulling back an index from a list. Python's is a list. We're pulling back an index that doesn't exist, and then we get an error. Cool. Okay, maybe you counted wrong with the indexes. Brilliant. Yeah, so there are. Maybe you didn't. 1, 2, 3, 4, 5. You should have brought back Michael. I know you're absolutely right, Shelby. I need to so quiz 2, question 2. I need to change that to a 6. So you didn't count wrong with the indexes. So you got that question right. So well done. Right. Didn't need to do that. Okay, everybody. So well done for getting to the end of this. What I want to do is bring up the last slide, which I've lost. I don't know where it is. Here, it's here, it's here, it's here. Right. Okay, so slideshow. So what have we looked at? We looked at refreshing. Oh, I've already done that. Right, next time. So next time we are going to look at variables as pointers and mutability. It does feel like, you know, gosh, a whole lot on variables as pointers and mutability, but they're fundamental to understanding about what is going on when you're creating variables and you're using data collections and things. So we're going to make sure that we understand how variables behave as pointers rather than buckets, because sometimes people think of variables as being buckets, but that doesn't really work, because when you've got 2 variables assigned to the same thing, you've only got 1 bucket. I don't know how that works. So labels is better, pointers is even better. And then we're going to look at the mutability of objects in Python. So, right, thank you all for bearing with me. Please fill in the feedback form. Should I paste it again? It is really useful because I have run over on this one. So maybe I should have had less content. But then you've also asked me some great questions, and answering your questions is more important than going through the stuff that I'm doing. Yeah, great. Thank you for being so interactive. It makes it much more fun for me, and I've learned things. And so hopefully I'll see you all next week. Enjoy your weekends. I hope you've got something fun planned. I have on Sunday. England are through to the Euros final. Maybe we'll win. We're definitely not the best side that's played so far in the tournament, but we've scraped our way through, and it's very exciting. Yeah, so if you're not doing anything on Sunday, you should watch the Euros and cheer for England. Okay, so take care. See you all next week.